Alright, in today's video we're going to start graphing our trig functions. And notice that I have the unit circle out again. And remember, I said ever since we learned about that unit circle, everything else we do is going to come back to that unit circle. And we're going to start off by we are only going to graph sine and cosine. We're not graphing tangent. And we're going to look at the general shapes of that sine and cosine. And the sketchpad demo will be coming tomorrow in class. We are going to look at the general form y equals a times sine of b of x. The only difference is replacing the sine with the cosine, where a and b are positive constants, so just numbers, and x is in radian measures. We're not going to deal with anything in degree measure, it's always going to be in radian measure. We're going to come back to the terminology and characteristics in just a second. We're going to look at the general shape first of a sine graph. Now we know that a whole circle, full-fledged around, is going to be 2 pi. We're going to break this into 4 pieces. So we are going to start at 0, and we're going to go all the way to 2 pi. If I cut that in half, I'm at pi. If I cut that in half, I'm at pi over 2. So I'm going by a half each time. So this is going to be 3 pi over 2. And if you look back to our unit circle, notice here's pi over 2, here's pi, 3 pi over 2, and 2 pi. So that's our whole way around this circle. If I'm at 0 radians and I'm graphing sine, what is my sine value? Sine of 0, I go to 0 radians. My sine is my y, so I'm at 0, 0. So here's my first point. Then I'm going to go to pi over 2. I want the sine value of pi over 2. Sine value is going to be 1. So when I have pi over 2, I have a value of 1. Next point is at pi. I want the sine value of pi, so I go to pi. My sine is y. I'm back at 0. Go to 3 pi over 2. I want the sine value of 3 pi over 2. I'm at negative 1. So this is a positive 1. This is a negative 1. Here's my next point. And the last point around the circle is 2 pi. At 2 pi, my sine value, my y value, is back at 0. This is going to give us the general shape of our sine graph. Your sine graph starting point is always going to be at 0, 0 until we have shifts coming, which will come later. Goes up, down, down, up. And it's going to continue in that direction the whole time. It's always going to follow that pattern. So if I go in the other direction, go to 2 pi, halfway is a negative pi over 2, a negative 3 pi over 2. So I'm always going to go up, down, down, up. So if I go in the other direction, I've got to go down, up, down. I want to make sure that it's always going to follow the same wave pattern. And this is my starting point. I'm always going to circle where my starting point is. So now that we've seen that sine graph, let's go ahead and go back and look at our terminology. Okay, so the domain of each function, we just look at our sine. Domain is possible x values, so that's moving left and right. My wave is going to forever go left and forever go right. So left, right, which means this is going to be all real numbers. If I want the range of each function, if I'm looking at sine and cosine, we talked about it the other day that the range of the value, my sine never gets smaller than negative 1, never gets bigger than a positive 1. It's going to go up and down. So this is a negative 1 to 1. The graph has a repeating pattern that continues indefinitely, so it's never going to stop. The shortest repeating portion is called a cycle. So when we look at our diagram here, from our starting point to 2 pi, that is going to be 1 cycle. When we graph, we're always going to graph 2 cycles. So here's another cycle. So we're always going to graph 2 cycles, and the horizontal length of each cycle is called the period. So in this case, the length of one period is going to be 2 pi. So when I talk about one cycle, the length of that one cycle is the period. And this one, in our regular sine graph without any transitions or movements to it, is going to be 2 pi. Next is the amplitude. The amplitude is the absolute value of A. And if you look back up, we have y equals A times the sine of bx. In this case, our A and our B are both 1. But the amplitude is always going to be the absolute value of A. The period, which we know in this case is 2 pi, but our formula to find period is 2 pi divided by the absolute value of B. Now each graph, as you graph it, should have 5 key x values per cycle or period. Oops. So as we look at this information, we already talked about the fact that our period was 2 pi, because 2 pi divided by 1 is just going to be 2 pi. The next thing that you're going to have to give me is the interval. And we haven't talked about the interval yet. The interval is the distance between each of your tick marks. And in order to find that, you take your period and you divide it by 4. So in this case, 2 pi divided by 4 gives us pi over 2. And you can see that the distance between each of these is pi over 2. 1 half, 1 half, 1 half. We're increasing by 1 half each time. And our amplitude is going to be 1, the absolute value of 1. And what the amplitude is showing is the distance, the vertical distance between each of your points. You're going to have 3 main lines in each graph. The highest point, the middle point, and the lowest point of your graph. It's always going to have points on those 3 pieces. It's never going to be in between or above or below. You're going to have 3 main levels to your graph. Okay, so now let's look at the cosine graph. We still don't have any A or B values, so our period is still going to go to 2 pi. We cut that in half, cut that in half. Our interval is going to be pi over 2. We haven't made any changes. We just want to look at the cosine instead of the sine. And these are all negative. So again, we already said that our period was 2 pi. Our interval was pi over 2. And our amplitude is 1. So we look at our graph, and we start at 0. When we look at our unit circle, if I want the cosine, which means I want the x value, at 0, I'm going to start up at 1. So a little bit different than the last one. If I go to pi over 2, my cosine over x value is at 0. Next we have pi. The x value is at negative 1. And 3 pi over 2, our x value is back up at 0. And at 2 pi, our x value is back at 1. So here's my starting point. I always circle that starting point. And that is what my general cosine graph is going to look like. And then we can go in the other direction. Remember, we have 3 levels. Here is the upper level, our middle level, and our lower level. We have our cosine. We are already at the top level, so we can't go any farther. We go until we hit the other crest. As soon as I hit the bottom crest, I go back up until it bounces to the top, and then it ends up coming back down. So it's going to bounce off those upper and lower bounds there. If we only look at one cycle here, sine starts at 0, and there's 1 cycle. Cosine starts at 1, and there's 1 cycle. If you look at all of this without focusing on the starting point, and this is why it's so important that you circle where you start, so I can see whether it's a sine or cosine graph, that's the big difference. If I were to look at this without that starting point, it's the same wave. A sine wave and a cosine wave are the exact same graph, just depending on where they're starting at. Alright, so again, let's compare from the last one. Our period, our 1 cycle, from here to here is going to be 1 cycle, which is also 1 period. That period is going to be 2 pi. The interval is the vertical distance between points. So here's your amplitude. You can see that I'm moving a distance of 1. From here to here, my vertical change in distance was 1. From here to here, it's the same thing. It's the same vertical distance between any of your 2 points. Alright, so let's go ahead and flip over to the back page. And let's talk about different transformations that we're going to see. So again, we have our general form, the A from before, the B, that is going to determine your period, your interval. Now we have other shifts, vertical shift and horizontal shift. You have minus h. Remember, anything inside of parentheses is going to go the opposite direction, and plus k. Inside is always horizontal, outside is always vertical. So your vertical shift is going to shift the graph k units. So that's going to be your vertical shifting. Your stretching is going to come from the amplitude. If the amplitude is negative, you have to flip your graph, and this is going to be a big difficulty. So this is going to be something that we're going to start and we want to pay attention to. Let's go ahead and get rid of our unit circle for now. Alright, let's look at our first graph. Y equals 3 sine of x. When I look at all of this, I see that our A is equal to 3. Our B is equal to 1. There's no h, there's no k. So we don't have any horizontal or vertical shifting. Our period is going to be 2 pi. Because remember that our period is 2 pi divided by b, and our b is just 1. We take that 2 pi, we divide it by 4 to get that our interval, our horizontal distance between each tick mark, is pi over 2. Our amplitude is 3, and our vertical shift is none. Okay, so let's go ahead and we set up our graph. We know that we start at 0. We're going all the way to 2 pi. I think it's easier to just cut things in half. I think you end up with the more evenly distributed points rather than trying to do 1, 1, 1, 1 like I did. Sometimes you end up short. So I go all the way to the end, our negative 2 pi. Try to eyeball cut that distance in half, and so forth. Cut each of those pieces in half. It doesn't have to be perfect, but make sure that it's relatively accurate. As we are graphing, we pay attention to which trig function is. In this case, we have our sine trig function. If you remember, and if you always forget, you can always watch the unit circle, but sine is always going to start at 0, 0. When we go to pi over 2, normally we go to 1, but our amplitude is 3. So what I have to do is I have to take that amplitude and I have to multiply it by 3, which means instead of starting at 1, 1 times 3 is 3. Now that's going to be the upper point of my graph. Then we go up, down, down, and then we have to go down to 3, negative 3. Oops. Down, and then up. Not forgetting that we have those 3 levels. Here is our upper level, our middle level, and then the lower bound of our graph. Because of that amplitude of 3, I guess I didn't draw that line very well, we won't go above 3, we won't go below 3. Our amplitude is the distance between each of our points. So as I traveled from here to here, this gave me an amplitude of 3. That vertical change is 3. So I went up 3, down 3, down 3, up 3. Remember, as soon as you hit that upper bound, it bounces until it hits the lower bound, and then it bounces back up. So here is going to be one cycle of our graph. If I want to go in the other direction, we're in the middle, so we have to go until we hit the lower bound, and then it bounces back up until we get to the top, and then it bounces back down. Here is going to be our second cycle, not forgetting to always circle that starting point. So the amplitude stretched our graph out. Instead of going from 0 to 1, having a vertical change of 1, we multiplied each point by 3. Now when we multiply 0 by 3, we still get 0. That's why we still have a starting point of 0, 0. Next graph, we look at cosine x plus 2. Here we see that we have an a value of 1, a b value of 2, and even though you may think this is your h, this is actually a k value of 2. If it was the h, it would be inside of parentheses. So no change to our period, no change to our interval. This time we have an amplitude of 1, but we have a vertical shift. Positive means that we're going to go up 2. As we start this, sometimes it's easier just to start with your general cosine graph. So we go ahead and set it up. Go in our other direction. And we know that in general, a cosine graph starts at 1, and that's at the top. Then it comes down, down, up, up, hitting, that's a little too far up, hitting those levels. We have an upper level of 1, a middle level, and then a lower level. It has to stay within those bounds. This is what a general cosine graph looks like with this as your starting point. Down, down, up, up. So here's a rough sketch. And remember, this is just representing cosine of x with no changes. Here we only have one slight change, and that slight change is that we are going up 2. So what I have to do is I have to take each of those points and move them up 2. So here I'm at 1. If I move that up 2, I'm now at 3. Here I'm at 0. I move up 2. I'm now at 2. I move -1 up 2. I'm at 1. I didn't space my points very well. So all I'm doing is taking each of my points and I'm moving it up 2. Here we're at 0, we go up 2. We're at 1, we go up 2 to 3. So now our upper limit is at the line 3. Our middle limit is at 2. And our lower limit is at 3. Notice how we still have that same shape, our cosine shape. All we did was move each of our points up 2 to represent that vertical shift. Same thing for the other direction. So we go down, down, up, up, showing that each of those points have shifted, going up 2. Now it doesn't matter. Some people prefer to draw the regular cosine, the regular sine graph, and then take that as a foundation and move from there. Other people prefer just to move it from the very beginning. It will take practice. Some of you eventually with lots of practice will do it the way we did the first one. Others of you will always never get comfortable enough not to have to draw the regular one. As long as you can get it right, because these graphs can be worth 8 to 10 points on a test, it's very important that you do whatever makes most sense for you. Okay, we still have 2 graphs left. Our next one is -2 sine x plus 1. So we have an a of -2. that means our amplitude is going to be 2 because our amplitude is the absolute value of the a value. But because it's negative, we have to flip it, which is going to come very, very important. Our b is equal to 1. We have no h. We have k is equal to 1, which means we have a vertical shift of up 1. Our period did not change. Our interval did not change. So go ahead and set up your graph. Alright, so what I did is I drew just a regular sine graph. That is your most basic sine graph with no transformations on it. We do have a couple transformations. We have an amplitude of 2, but we have to flip, and we have to do a vertical shift of up 1. So what I do is I multiply each of them, in a sense, by -2 because -2 is that a value. So 0 times -2 doesn't change anything. 1 times -2 makes it a -2. So that point is now down at a -2 instead of at a +1. 0 times -2 is still 0. -1 times the -2 now puts us up at a +2. And 0 times 0. So notice how before we were going up, down, down, up, that negative makes it go down, up, up, down. We have reflected it. But we haven't taken into case yet our vertical shift. So that means I also have to push each of my points up 1. So 0 goes up 1 to 1. -2 goes up to -1. Again, each of these points are just going up 1 to account for that vertical shift. Up 1. And up 1. So now our amplitude is 2. Our starting point is at 0, -1. Because my amplitude is 2, that vertical change in each point is going to be a distance of 2. So we went down 2 units, we went up 2 units, up 2 more, down 2. Normally before it was continuing going up, but now it's going to continue going down. So our levels are at 3, the amplitude is 2, so my next level is going to be at 1, going down 2 units. Down 2 units from 1 is at a -1. So those are going to be my boundary points. I started in the middle, so we have to go up, down, down, up, hitting those 3 levels. And remember, we don't bounce until we hit level, so that's going to continue going up until it comes back down, and so forth, continuing. So we did our amplitude of a -2. Because we did that, it had to flip directions. Okay, we have one more left. I know this is a very, very long video. I want you to press pause and try this last one all on your own. Okay, this was a difficult one. First, we start out with the fact that we have a cosine graph. When we start with a cosine graph, our general form, our y equals cosine of x, starts at the top, the topmost of our peak, and then it goes down, down, up, up. What happened was we had an amplitude of 1/2. Our general graph has an amplitude of 1, so our vertical distance, it goes up and down by 1 each time. So we go from 1 to 0 to -1 to 0 to 1. Our amplitude changed to 1/2. So we had to take each of those numbers and multiply it by 1/2. So 1 times 1/2, I'm now at 1/2. 0 times 1/2, I'm still at 0. And -1 times 1/2 is a -1/2. So I'm multiplying each of my points by 1/2, but then I have to take into consider that down motion of 3. So I'm at 1/2, and then I go down to a -1/2, down to a -1 1/2, down a third time to a -2 1/2. So I take care of the amplitude first. I multiply by whatever the amplitude is, and then I do my shift of down 3, down 3, down 3, down 3, down 3. So now when I look at my new lines, I have my upper bound, which is starting at -2 1/2. My amplitude is 1/2, so my middle bound, just 1/2 down from that, is a -3, and then at a -3 1/2. Cosine starts at the top of the wave, so it goes down, down, up, then it makes its way back down. On the other direction, it goes down, down, up, making its way back down. Okay, I know we are finally finished.